Assalamu alaikum. We were talking about automated software testing and test tools that are used to automate the process of software testing in the last lecture. Today we will take up 3 topics in software testing, and it is going to be our last lecture in series of lectures on software testing. The topics that we will cover today are test cases. Software testers will talk about their responsibilities, and we will also talk about the software testing completion criteria, that is, when do we stop testing. So let's begin our discussion on test cases. In this discussion, we will see why it is important to generate manually or with the help of a test tool those test cases which will enable us to find defects in the software products. That is, what are the characteristics, and we will also see the problems which we face in certain test cases. So a test case describes how a test will be conducted. It also describes the input values and the expected output values or expected results. So development of test cases assist us in keeping track of what is tested, when it is tested, and the outcome of the software test. Obviously, if a test results in the detection of an error or observation of a failure, a documented test case will help us, will make it easier for the developer to recreate that situation. Because when we are conducting tests, we are actually trying to observe failures. We are trying to break the software so that we can see the failure. And if the test case is appropriately documented, then the programmers who are responsible for making repairs in the software will use that same test case to recreate that environment, recreate that scenario. And so a documented test case helps us in the follow-up and analysis of the failure, and it ultimately helps us in the detection and removal of the software defect. So selecting a good test case is the single most important task that software testers do. Improper selection can result in testing too much, testing too little, or testing the wrong things. So remember our discussion on testing techniques and testing strategy. We at that time talked about the importance of test cases. Now we are specifically discussing the reasons why we need to select good test cases, to generate good test cases. Intelligently weighing the risks and reducing the infinite possibilities to manageable effective test is the ultimate responsibility of a software tester. And this comes with domain knowledge, this comes with expertise, and obviously with education and training. So software testing or selection of good test cases or generation of good test cases is not an ad hoc activity. It requires thinking, it requires hard work, and it also requires that you build experience as you develop more and more test cases. There's another interesting observation and advice that when you are running test cases, when you are performing tests, it is advisable that you should run the test to pass cases first. These are those cases where you would normally use software. So this captures the normal execution of the software system. It is important to see if the software actually behaves the way it is supposed to behave in normal circumstances. And you will be surprised that number of defects found even in the normal behavior are quite high. And so there are two ways you can perform software testing. One is that you can run tests to pass, and second is then you can run tests to fail, so that you try to break software. What is suggested is that you should run tests to pass cases first, so that you can eliminate all those defects which are encountered in the normal execution of the software system. And once you've done that, then you can select the pass to fail cases and see if invalid input is accepted or not, or how does the software behave in abnormal circumstances or when aberrant conditions or events are happening. There are no standard or simple rules for designing test cases. As I've said, that this is the single most important responsibility of test case designers. So they need work, they need knowledge, and they need experience in order for them to generate good test cases. Test cases should be designed for testing each function, and as a result, the expected output and expected results should also be documented along with that. Secondly, in order to determine what will break the system, a software tester should be creative and want to break the system, should think ways in which software would behave abnormally. And so that is why we call it psychologically destructive activity. There is another important aspect, and that is that the test cases should be repeatable, which means that whenever a test case is applied, it should produce the same results. Unless, of course, if the domain is in real-time system, because the underlying parameters and conditions may change. But in ordinary software applications, the test cases should be repeatable and produce the same results every time they are applied in a test. The test cases should be organized and developed around system requirements and for key functions of the software system. So now you see that everything in a software engineering project is basically driven by the requirements. And so, as the case with software testing, that whenever you want to generate a good set of test cases, they should be basically driven by and based on requirements that you have agreed in the requirements model. The test design emphasizes the type of test needed to test the requirements. There are a number of types of tests that we have discussed when we talked about testing strategies. The test design also emphasizes the algorithm, that is how the test will be run and how all the requirements will be addressed by the tests that are being developed. You know that good test case catches errors or defects, and that's the philosophy that we will promote and work on when we talk about software testing and designing good test cases. What we ideally would want is that we should have test cases which cover as many related functions as possible. If we are successful in doing that, then it means that we are saving the number of, we are reducing the number of test cases, because with fewer test cases we are testing more functions, more than one function, and as a result we are reducing the time and effort in conducting software tests. But needs to be cautioned also that this does not mean that we should compromise the quality of software testing. The test cases, if they test more than one function, should be thoroughly designed, and they should be organized so that if there is, they should be organized in a fashion that they clearly develop the relationship between the functions that they test. Because if one test case, if there is an error in such a test case which tests multiple functions, then it can be difficult to relate that error with any function, with any specific function, if due care is not taken. Typically, a test case contains an identifier, the name of the person who is going to execute the test, the date on which the test was executed, and the version of the system that was tested. It also contains the description of the functions to be tested and a list of actions to be carried out. A test case also contains input values. It contains the expected results or output values, and in most cases the success of a test case depends on obtaining the predefined expected results. And it also should capture actual results, that is, output received when the test was executed. You need to indicate whether or not the errors were detected, and if so, that is, errors were detected, then you need to complete a problem report. Now, this is a very comprehensive information for a test case, but it is going to help us in documenting and ensuring that no shortcuts have been taken in performing software testing, and in this information can be used to assure the customers that the functionality that was promised has actually been built and tested in the software product. Let's now talk a little bit about some words and phrases that should raise an alarm when you see them in the requirements. These words and phrases will lead you to develop test cases which can be erroneous. If you find these words or phrases in a requirements document and then you are trying to bake and trying to develop or generate test cases, you should be very careful, and you should analyze the requirements document and discuss with the requirements engineers and other concerned professionals before finalizing the test cases. And there are a few sets of those words and phrases, and I'll read them first and then you discuss them with you on what are the different problems that you will face. The first set of words is like always, every, all, none, or never. If you see these words, you know that they denote something as certain or absolute. See, the word always, every, all, none, or never mean or contain certainty in them, or convey certainty either on the positive side or on the negative side. Now, before you generate test cases or develop test cases, make sure that indeed that certainty is meant and conveyed in those situations. As a good test case designer, you should try to think of cases that violate this certainty. The second set of words or phrases is certainly, therefore, clearly, obviously, and evidently. These words tend to persuade you into accepting something as given. When you are trying to come up with or generate good test cases, don't fall into this trap. Don't fall into this trap until you have investigated exactly what these words or phrases mean. Then the next set of words and phrases is some, sometimes, often, usually, ordinarily, customarily, most, and mostly. These words are too vague, and I'll give you an example. For it is impossible to test a feature that operates sometimes, or it is impossible to test a feature that operates usually, customarily, or mostly. And so, whenever you encounter these words in your requirements document or in your discussions with the concerned professionals, you have to be very careful. You have to challenge the situation, and before you commit and finalize the test cases, you need to get certainty and assure yourself that what is meant by these words or phrases. Then we have another set, and that is etc., and so forth, and so on, and such as. These are like lists that finish with words such as these aren't testable. You need more explanation. You're not sure what etc. means in the context. What is so forth meant? Or what does so on and such as mean when you are writing test cases, when you want to develop good test cases? So you have to be careful. You need more explanation, you need to question, you need to ask the concerned people about what is meant here. Then another set is good, fast, cheap, efficient, small, or stable. These are unquantifiable terms. These are clearly not testable. What does good mean? How fast is fast? Then you have another set which contains the words handled, processed, rejected, skipped, or eliminated. These terms can handle large amounts of functionality that need to be specified. You can use these terms in broad contexts, and so you need to be sure exactly what does handled or processed or rejected means. And if they can be broken down further, you need to break down that functionality. And then you have if condition, then, and nothing on the else side. That is, look for those statements in the requirements document that have if statements, if clauses, but no else. Ask yourself, what will happen if doesn't happen? That is, the condition is not met. What would happen? Is there an alternative situation or not? These words and phrases will help you in selecting and generating good test cases. Now you are seeing on the screen characteristics of a test case. If a test case is repeatable, means it's consistent. If it's destructive, it means it detects discrepancies or defects. If it's manageable, it means that the results can be traced. So we need to strive for those test cases which have these characteristics. There are a number of types of test cases also. There are functional test cases, there are computation and boundary analysis test cases, there are cause-effect and logic test cases, and then there are security test cases. So depending on the testing approach, you need to develop appropriate test cases. Let us now discuss some considerations for test case development. Number one, all valid system input must be accepted. That is, you cannot deny valid input while selecting or developing test cases. Number two, all invalid system input must be rejected with clear error messages. That is also very obvious, that test cases should not accept invalid input. But if invalid input is given, that should be rejected with clear messages. All functions, including generation of reports, should be tested. Any reports generated by the system should be tested and verified for correctness. And any interfacing systems must be invoked and verified that the data is passed to and from the interfacing system. I just want to mention one thing, that if your new software system interfaces with existing systems, you should give due care and thought in the interface testing, because this is one area where a lot of problems occur while integrating, and when even in large systems it has been reported that interfaces don't match when the software products or services are developed. So this is one area which needs special attention in software testing. Let's talk a little bit about bad test cases. The error density in software test cases is often higher than the error density in software product. This is because care is not taken in designing and developing test cases so that the errors are injected and defects found their way in test cases. If as much care is given to the development of software test cases as to the software product, then we will definitely not face such problems. Sometimes more than 15% of total number of test cases created have errors in themselves, and 50% of repair effort is applied towards test cases themselves. And this is really a very disturbing number, because instead of focusing on repairing defects in the software, we are spending our time trying to repair defects in the test cases. And as a result, if you execute test cases, run tests based on bad test cases, then that adds no value in terms of your software testing effort or in terms of quality assurance activities. So there is implied need for greater rigor in building and validating test cases and test libraries. So as I have said this before multiple times, that it requires planning and it requires thinking and commitment to develop good test cases. Testing limits and ranges where those included in the test case themselves are incorrect. These are some of the problems that actually happen or found in the test cases. So and also testing for numeric values where the test data contains wrong data or wrong information, test cases derived from specifications or user requirements which contained undetected errors are naturally going to pass those errors in the test cases. There is accidental redundancy of test cases or test libraries. This number can be as high as 30%, that 30% of the test cases are performing redundancy tests. And in some cases, you find that there are gaps or portions of application for which there is no test case. And this typically results because there are gaps in the requirements. So we need to conduct formal technical reviews or inspections in order to develop good test cases. Those test cases which find defects, which allow us to perform as much coverage testing as possible. Let's now talk about some observations regarding test cases. Test cases created by programmers themselves have the lowest probability of being duplicated, but the highest probability of containing errors or bugs. So whenever the programmers are creating test cases, they will not contain duplicity or redundancy, but they will contain errors. Test cases created by test or quality assurance personnel have the greatest possibility of redundancy, but lower probability of containing errors, because these are typically professionals. They take their assignments of creating test cases more seriously, and so their products that are test cases do not contain as many errors, but since they want to cover everything, you can find redundancy in them. So test case generation and test case development is an area which requires more research, and research in the universities and research in those organizations which are focused on software engineering research have openings, have research programs focused on software testing, and those interested young professionals and young students who are interested in software testing can take up this area if they are inclined to do so, obviously. Let's now talk a little bit about software testers. Who should do software testing? As we have seen up to this point, certain professionals are involved, and that include the programmers themselves. Then we can have professional software testers. Then there is another group that is professional quality assurance personnel. So these are the three independent groups, in addition to obviously the customer. But what happens is that a combination of all of these people, all of these human resources, participate in software testing. The productivity of every group of software testers is different. The defect removal efficiency of black box testing is higher when performed by test personnel or by quality assurance personnel rather than by the developers themselves. So what this means is that independent testers, professional testers, or professional QA staff is more efficient in finding defects for black box testing. On the other hand, black box testing performed by clients varies widely. That is, their performance varies widely, but efficiency rises with the number of clients involved. And so if the number of clients is higher, efficiency of finding defects and conducting black box testing becomes better. For usability problems, testing by clients themselves outranks all other forms of testing. So if you have to perform usability testing, your clients are the best bet. They would be able to test the product much more efficiently than all other testers. The defect removal efficiency of white box, subroutine, and unit testing is the highest when performed by the developers themselves. That's why we had said this before, that usually white box testing is performed by the programmers or developers themselves, because they know the ins and outs of the software programs better than anyone else. The defect removal efficiency of specialized kinds of white box testing, such as that was Y2K or viral protection testing, is highest when performed by professional test personnel rather than by the developers themselves. Because again, this is specialized testing, and test professionals are experts in their own area. They are focused and trained to find defects. So whenever we have specialized testing, even if that is white box testing, professional test professionals and QA professionals are more efficient than the developers. So on average, we can say that developers do 31% of testing. Professional test personnel do almost about the same 31%, while QA personnel, quality assurance personnel, do 18% of software testing. And clients and customers do something like 20% of software testing. And so this was our discussion on responsibilities or observations about software testing. Software testers. Every class of software tester has his or her own strengths and weaknesses. Even if we are successful in performing testing, the debugging effort has to be done by the developers. And as we mentioned when we were talking about software debugging, that the productivity and efficiency in the debugging activity varies substantially from programmer to programmer. And so, especially for white box testing, since typical white box testing is performed by the developers, this efficiency and productivity also varies. Certain programmers are very good in finding defects, while others are not, even if they have the same education and training backgrounds. And so in order for software testing to improve, the software testers need to find creative ways to perform software testing. Now let's talk a little bit about the very important question, and that is when to stop testing. Actually, you cannot ever guarantee that there are no defects in the software product, especially if the software product is of any real complex nature. So you are never done testing. The burden simply shifts from you as a development team or you as a tester to your customer. So if I have to very simply answer this question, when do you stop testing? The two choices that come to mind are that you are done testing when you run out of money or when you run out of time. So there is no definitive answer, but we need to be a little bit more specific on this So on the small scale or a local scale, we can ask when to stop testing for a specific test activity. But on the global scale, we can ask when to stop all major test activities. Because the testing phase is usually the last major development task before product is released to the customer. So this question can be rephrased as when to stop testing and release the product to the customer. So again, these are two sets of questions, and we will take them one by one. You can use what is called the resource-based criteria, where decisions are made based on the resource consumptions. And I've already answered this question for you. The most commonly used stopping criteria here are stop when you run out of time or stop when you run out of money. And these are the two choices that I've given you before when I started discussion on this topic. However, if you pay a little bit attention to these answers, you would notice that such criteria are irresponsible as far as product quality is concerned, because we are not taking product quality into account by stopping when we run out of time or by stopping when we run out of money. But if you look at from a different perspective, that is, these criteria may be employed if product schedule or product costs are the dominant factors or dominant concerns for the product in question. And so if you look at the question from the perspective of consumption of resources, that is resource-based perspective, then your answers may be accurate, may be correct, and may be justified. But if you look at it from the activity-based criteria, and you can ask the question, or you can answer the question commonly in the form, stop when you complete planned test activity. And here you can be sure about your answers that you have met your tasks, the tasks that you had planned long before software testing actually started. So this criteria implicitly assumes the effectiveness of test activities in ensuring the quality of the software product. Because we, when we're planning test activities, were keeping software quality in mind. And that was our prime objective in performing the test planning and preparation. However, this assumption needs evidence. And unless we provide strong statistical evidence based on actual data from the project concerned, we cannot claim with certainty that we have met our quality criteria. And a number of researchers in this area have proposed statistical approaches in which a model is developed and that model is used to determine, let's say, for example, the probability of that determines the reliability of a system. And so they run the software product for, say, 1,000 hours, 1,000 CPU hours, 1,000 failure-free CPU hours. And based on that operation, a probability is developed that the system is reliable. And so unless statistical data is used, we cannot claim with 100% certainty that we have met our activity-based or quality assurance-based criteria for stopping software testing activity. Today we have discussed software test cases. These test cases are very important in performing software testing activity. They are the backbone of software testing activity. We discussed the characteristics of good test cases. We also discussed the characteristics of bad test cases as to why, if care is not provided, test cases become a problem in themselves. And we also discussed the errors and defects or problems that are found in test cases. Then we all discussed the characteristics and responsibilities and certain observations on software testers, their efficiencies, their productivities with respect to different testing techniques. And lastly, we talked about the most important question in many professionals' mind as when we finish testing, when we stop testing. And we discussed two approaches, resource-based and activity-based approaches on stopping software testing. This brings to conclusion the lectures on software testing for this course. Software testing is and will continue to be an important quality assurance mechanism in software projects, for software products. The industry will continue to devise ways and means to improve this very important activity so that the productivity of software professionals and software testers continue to improve. We will continue to find new ways in which new techniques, new approaches to software testing are introduced to the industry. Both the academics side, the academia, and the industry will continue to provide training and education on these new techniques and new software testing approaches. And research will continue to improve different sub-activities in software testing. The ultimate goal of all software engineering activities, and especially software testing, is to ensure high quality software products and services. In the next lecture, we will take up another very interesting topic that relates to software quality, and that topic is software configuration management. So until that time, I take leave of you. See you then.